Let me draw the circuit to explain it. It's a very good question and a little bit trickier. The way the things are there, little bit some difficulty we do face in taking a decision, especially in exams, little bit difficult. You cannot take risk also. So such questions, I think, better to keep in the end. If there's no native marking, okay, attempt it. If the native marking is there, little bit you have to be alert. Okay, this is the circuit what we have, and this is the terminals across which we should find out. Okay, this is A naught, B naught. So let's go for charge distribution. The charge comes here. You see this is a 2 farad, 6 farad. So can you put same charge in these two branches? No, it should be different. So the charge distribution has to be different. So here, so you just show like this, the enough flow of charge, or put it here, the flow of charge Q1, here Q2. Capital Q1 will write it. So this Q1 now will branch it Q2, Q3. Now the question comes, what will happen? So why charges you are putting different? Q1 is not equal to Q2. There's a strict condition. Here the charge Q2, this will be Q3. After this is what the headache will start now. So this is 5 farad. I'll indicate the capacitance. I missed this. This will be 3 farad. Anybody, can you suggest what actually happens? I'm giving opportunity to express your ideas. So it's quite very simple. This charge, in fact, will not branch. Will go like this. This charge which is there will branch it, and here it will not branch. The reason for that is like, so, okay, this I have to indicate all this set, no? 15 farad, 12 farad. I think everything I indicate. Oh, yeah. Now let's get into the discussion. This 5 farad is there. The charge here is Q2. Okay, this is Q2 now. So now this charge what will happen will not branch, will come here. Q2, so that the different colors at least I'll indicate so that it will be easy for you. Q3, And this Q3 will finally will come here. Q3 plus Q2 should be equal to Q1. We'll get the same thing. Now this Q3 will branch here. We'll branch it as Q4, Q5. Again, it will not branch Q4. So this will be Q4. Q4 plus Q5 will combine, will become Q3. Q2 plus Q3 will combine, will become Q1. This side also will the same thing. So here we took symbol Q3, yeah, Q4, this Q2, Q4, it will be like this, huh? Q4, Q5, and this will be Q4, and this is Q3. Q3 plus Q2, again it is Q1. So I'll simplest thing, I'll put a path, the one which will not branch. This is a one path. This will not branch. Similarly for this. Okay, there's a thing. And the charge which will come will not branch. Sir, how do we come to know? How do we come to know that we should think like this? There's a primary question what you can ask a teacher here now. You go for the different charges. So finally what happens when you split up this charge, the charge will not be conserved. If you want to try it. And what is the basic reason? If you draw this a line, to draw this a line. So instead of drawing this line, better you draw a line like this. So the current will be like it could, or so let me show in this way only. So this will be a symmetric one. This line will be a symmetric line. About this symmetric line, what the current will have a mirror image is what we call. There's like a theorem. They say like practically in the lab when we go and check it, no, what current flows here, the same current flows. That's why looking at that laboratory condition, they brought this particular theorem, that one. So rather than fighting on paper, it's a laboratory situation.